Hey, Jake Williams from Edition InfoSec here. I want to chat a little bit about supply chain security. If you've been following me for any length of time, you know that I am big on supply chain security, and it's one of these things that a lot of people are starting to talk about now. Really hasn't been talked about a lot before. Probably should have been a little bit more. Dan Gooden actually broke a story at the end of last week about a malicious Python package that has been installed on a number of not just a number of different sites directly, but also the package is interesting, or at least the attack is interesting in that this package not only got deployed from the official repository, it also got pushed into downstream mirror repositories as well. Unfortunately, that means that we don't know the full damage, right? We know that it was installed on or downloaded at least 170 times. We know that at least 50 of those installs or 50 of those downloads were going over to mirror sites, and then an unknown number of downloads from those mirror sites directly, right? So I am, and of course this could propagate outwards, right? I'm exceedingly interested in this. Now, what's really interesting about this, a couple of things right off the bat. If you're a Python fan like I am, and you like to write Python scripts that are cross-platform, this is going to speak to you. The name of the module, which I've used on a couple of occasions, called Colorama. And basically, what that allows you to do is set up terminal escapes and screen coloring and whatnot, so that if you wanted to have like colored print or whatever in your terminal, it'll work the same whether you're in Linux or whether you're in Windows, right? So Colorama predominantly gets installed on Windows machines, because I'm going to be straight up and say, look, it's trivial to do all this in Linux anyway. The only reason that you really install this specifically is that you're going to Windows. Well, it turns out here that that when installing this on Windows, it actually drops a Visual Basic script that is basically set up to steal some credentials. It's a credential stuffer, I guess, effectively, if you wanted to think of it that way. Mostly surrounding, I believe, if memory recalls correctly, the some crypto related stuff, not encryption, but cryptocurrency related stuff. Surprise, cybercrime and crypto again. But look, that's really not the important part to me. As I read this story, a couple of things hit me. First off, and I've talked about this to as many people as will listen. Forget the fact that this is the illegitimate copy of the plugin. By the way, I should probably mention Colorama is spelled with Color, right? The U.S. English spelling, whereas the Poison package is spelled with the British English spelling. So look, Brits, if you just got on board with the right spelling, you wouldn't have fallen victim to this. Although I have to throw out there, that is pretty brilliant. Colorama, to trick, I guess, is what it comes down to. So poor folks using Colorama here. Now, even if they uninstall the package, obviously this Visual Basic script has been set up with registered persistence. That happens during installation. Obviously, installation happens as a privileged user, system or admin on Windows. I guess you might step back and look and go, well, at least this was it, right? It wasn't another back door. It wasn't a bunch of other. But man, that still is pretty nasty when it comes down to it. Damage could have been significantly worse than it was. Ransomware, for instance, could have been deployed. Now, if I was an attacker and I was going to do this, I want to separate out the ransomware from the immediate deployment of that script. But still, what leads to this, right? Are these people being careless? Well, no. The thing's already camouflaged, right? It would be very, very easy, particularly again if you're not in the U.S. and you don't spell color the way we do. It would be very, very easy to drop in and use Colorama with the English spelling, British English spelling. But as we even think about that though, why are we not? Man, what isn't this all open source anyway? Well, Look, one of the problems we run into with Windows and Python is that typically you're going to need, or in many cases, you need DLLs behind that, right? So, in the case of Linux, and I'm not saying that Linux is automatically better, it's not. Most people don't review any of the source at all. They just type /configure ampersand make ampersand make install, all right? And bam, it's gone. Or in the case of Python space setup.py, and so totally get it, right? Again, here most people aren't reviewing the code anyway, but understand that on the back end, we already have these libraries built, right? And so things like, for instance, gosh, I'm trying to think of a good example here. SSL, right? So libSSL. As we get in and we use Python with libSSL or anything that depends on it, the shared object library is already there on Linux, right? So let's assume for a moment, because when we talk about supply chain, you have to have trust in something to start talking about everything else. Let's say that I have trust in libSSL. I'm now going to basically call into exported functions of libSSL.so. Right? So okay, got that. What about on Windows? Do we have a libSSL? It turns out, not so much. I mean, yes, you do, right? There are a number of encryption DLLs or DLLs that deal with encryption on Windows, but we don't have one that functions the same way that GNU libSSL does. And so one of the things that we end up needing then is we need a copy of a DLL that exports the same functions with the same arguments, all that stuff, so that it works identically to the way libSSL is supposed to. Okay, well, cool. Where does that come from? Well, okay, well, this is where things get a little more complex because, as it turns out, somebody, usually an untrusted third party, compiles these and then creates an install package with the Python script itself. So here you're installing DLLs. Now, most of the time these are not code signed. Most of the time the build process is very suffers from a lack of transparency. We've got a lot of problems here kicking around, and that doesn't just stop with, hey, let me go ahead and review the Python source. The Python source could be 100% identical, and then me stepping back and saying, hey, I've got this compiled libSSL. Is there anything extra in here, dude? That's like massive reverse engineering task, right? So here, a lot of people are like, well, we'll just make sure it's digitally signed. Well, brother, I got bad news for you. That ain't going to work in the case of most Windows Python deployments with any native code. Now, I guess we have to kind of step back and ask, is that okay? I'm not touching that with a 10-foot pole, right? Obviously, get your stuff from get your software from a good source. But here we have even the official resource, the PyPi download site, again had an illegitimate copy there, right? And again, it was typo squatted with one character off, and in fact, a very common misspelling or correct spelling depending on which side of the pond you're on, right? So here, we step back and it's clear to see how the deployments actually occurred. It's clear to see how users were being tricked, and not just regular users. These are system admins, right? That are large and developers that are installing this stuff. So again, your target wasn't my mom or my dad, basically clicking on some 419 scam or something. The target was, had to be convincing enough to trip up system admins, right? So obviously, again, a lot going on here. But I do want to mention this because, again, it is yet another example of a supply chain attack, and certainly this won't be the only one that we see. Supply chain is big in the news right now because of Supermicro, of course, and that's on the hardware side, right? But that's like nation state level stuff. This is not. This is anybody starting up a project that is a one or two character misspelling, or even better, another nationality spelling of the same thing, and from there, man, it's just game on, right? These are folks that are then installing your software, running it as admin, and again, I think the reason this ends up getting caught ultimately is because of malware, right? It directly deployed. And let's be fair, Visual Basic scripts persisting in the registry. I mean, that's not. I don't want to say that's so abnormal that it's automatically malicious, but it's not stealthy, right? That's the one thing I can tell you for sure. It ain't stealthy. Anyway, I guess this is a good spot to go ahead and wrap this one up here. I will mention that a while back, Rendition InfoSec released a supply chain risk evaluation and threat hunting, SCREATH, or SCREATH. We released that, and you can find that. I'll link it here, of course, in the video. But at renditioninfosec.com/SCREATH. And you can download a copy of the supply chain risk evaluation and threat hunting framework there. It's in version 0.1. We're going to roll a 0.2 here, hopefully before the first of the year, and then hopefully have a more final 1.0 version rolling into next year. The reason that we wanted to do that in general is that we recognize the supply chain problem, recognize how hard it is with these dependencies. And by the way, this is something that would have rated, on Screed. This is an additional external dependency. We recognize for every external dependency you have, that's going to add risk. Right now, again, your software may have been great, but if your software requires this, right, requires in this case here the Colorama, then understand and look, don't be like, oh, my software would never require a Colorama. Yeah, I got that, but it's requiring some external dependencies, and if it does, any external dependency, of course, not only does that increase, definitely risk around, basically you maintaining your software on the back end, but also risk around your users deploying the correct version of the libraries. Now, look, if you take care of all of that for them, great. But then we still have to worry about, did you do it correctly, right? And it only takes once to screw that up. And I don't mean you necessarily and whoever's watching the video, but you understand where I'm going here. Ultimately, complexity is the enemy of security. We know that. And this supply chain thing, particularly as you get into Windows and these third-party libraries for Python, is just an absolute nightmare, right? So anyway, look, bottom line, be vigilant. Think about your supply chain security. If you're a software developer, think about how you can safely deploy these dependencies. Think about how you can provide, trust for people that want to know about the security for your dependencies. Anyway, it's a great spot to cut it off here. Jake Williams from Edition InfoSec, signing off.